In this video, we are going to continue with the spheres. Here, we are given a solid wooden toy which is in form of a cone mounted on a hemisphere. So we have hemisphere here, and then it is the cone is mounted on that, means placed on that. The radii of the hemisphere and the base of the cone are 4.2 centimeter. That means radius for both the figures, for both the shapes, is 4.2 centimeters, right? Each, and the total height of toy is 10.2 centimeters. Total height of the toy is given 10.2 centimeters. We have to calculate the volume of the wood used in the toy. Now we can calculate the volume of the wood used in the toy as volume of the cone plus volume of this hemisphere. For hemisphere, we know it is 2 by 3 pi r cube. Only r we require, so that we have. For cone, we require height also. But height of the cone is not given. Height of the entire toy is given. So how do we calculate the height of the cone? Now see, if you look at this height, this is also the radius of the hemisphere. So this is also the height, right? So this part will also be 4.2. This will be 4.2. So if you subtract 4.2 from 10.2, you will get the height of the cone here, right? So let's calculate the height of the cone. Height of cone will be 10.2 minus 4.2. So 0, that is 6 centimeters. So we got h as 6 centimeters. Now for cone also, we have radius as well as height. We can calculate the volume of cone. We can also calculate the volume of hemisphere. Add that in order to get the volume of the wood used to make this toy. So let's proceed. We can write that volume of wood used is equal to volume of conical part plus volume of hemisphere, right? So volume of cone we know is 1 by 3 pi r is same, so r square into capital H, plus volume of hemisphere is 2 by 3 pi r cube. So we can take 1 by 3 common, we can take pi also common, and we can take r square also common. So what is left inside? We are left with this h plus 2r, right? So let's substitute the values. 1 by 3 into 22 by 7, r is 42 by 10 into 42 by 10, and this h we have calculated as 6 plus this will be 2 into 42 by 10, right? So 2 21s are 2 5s are. So finally we have 7 6 are 3 2s are 2 5s are. So 2 2s are 2 1s are 2 5s are. So we have 22 into 21 upon 25 into, here we have 21 2s are 42. So if we take 5 as LCM, 5 6 are 30 plus 42, right? So that gives us 22 into 21 upon 25 into 72 upon 5. So which is equal to 22 into 21 into 72 upon 125, and that is equal to 266.112 centimeter cube. So you have found the volume of the wood used. Now he wants you to calculate the total surface area of this figure. So how will you find the total surface area? One will be this external part of the cone. So that is total surface area will be, let me use another color, will be pi RL outside this and this part outside. So this is half of the area of the surface area of the sphere, that is 2 pi r square, right? R is same, so you can take pi and r as common. Inside you will get L plus 2r. So pi is 22 by 7, r is your 42 by 10, L. Now you need to calculate this L. Now we know that L square is equal to h square plus r square, right? So this L square will be, h you have 6 square and r you have 4.2 whole square. So your L square is equal to 36 plus this is 4 4s are 16, so 17.64. so L square will be 53.64 and your L will be 7.3 centimeters. So let's take this L here as 7.3 centimeters plus 2r, 2 into 4.2. So 7 6 are 42, 2 11s are 2 5s are, so you have 66 divided by 5 into 7.3 plus 2 2s are 4, 2s are 8.4. So finally you have this as 66 upon 5 into how much is that? 7 15. So 157 upon 10, right? So that is equal to 66 into 157 upon 50. So which is equal to your 207.24 centimeter square. Fine. Okay. Now next one. In the next sum, you are given a figure. It is a metal container in the form of cylinder, right? And it is surmounted by a hemisphere. So a hemisphere is placed on top of it. The internal height of the cylinder is 7 meters. So height is 7 meters and the internal radius is, so r is 3.5 meters. He wants you to calculate the total area of the internal surface. Now the total area of the internal surface will be the surface area of, curved surface area of this cylinder and curved surface area of this hemisphere, right? Excluding the base, you don't have to take into consideration the base and the internal volume. Now volume will also be the volume of the cylinder plus volume of this hemisphere. So let's first calculate the first part. First part is total area of the internal surface. So if we take internal surface area, that is curved surface area of this, it will be 2 pi r square for hemisphere, and for cylinder it will be 2 pi RH, right? You can take 2 pi r common, you will get r plus h. Now you have the values, so let's substitute the values. 2 into 22 by 7 into r is 35 by 10, and this is how much? 3.5 plus 7, right? So 7 5s are 5 2s are 2 and 2 will go, so we are left with only 22 into 10.5, so which is 22 into 105 upon 10. So 5 2s are 5 1s are 5 2s are 2, 11s are, so you have 11 into 21, which is equal to 231 meter square. So you have found the total internal surface excluding the base of this figure. Now second, you have to calculate the internal volume. Now that internal volume will be the volume of this hemisphere plus volume of this cylinder. So volume of the hemisphere is 2 by 3 pi r cube plus pi r square and h, right? What can we take common? We can take common pi and r square. Inside we will be left with 2 by 3 r and plus h. So let's substitute the values now. 22 by 7 r is 35 by 10 into 35 by 10 into 2 into 3.5 upon this 3 plus h is 7, right? So 7 5s are, 5 2s are, 2 11s are, 5 7s are, 5 2s are. So you got 77 by 2 into 7 by 3 plus 7. 3.5 into 2 is okay. So that is 77 by 2. If you can take 3 LCM here, 7 plus 21. So that gives you 77 by 2 into 28 by 3. 2 1s are, 2 4s are. So you have 77 into 14 divided by 3, which is equal to 359.33 centimeter cube.